All right. So yeah, really excited to be here and have Alexander Kvamme from Echo AI, CEO and co-founder, with me. And my name is Arjun Bansal, CEO and co-founder of Log10. And excited to share some of the work we've been doing in deploying GenAI for enterprises. Particularly excited about Alex's work at Echo AI, where they've been making LLMs work in a very reliable way in a customer analytics, customer support context. So who amongst us hasn't had a bad experience with customer support? And I feel like the type of work Echo AI is doing is helping make that experience a lot better for everybody. And so we'll start this off with Alex going over a bit of the work they've done, and then I'll come on in a few minutes here and talk through how we've helped them through that journey. Over to you, Alex.
Great, thanks. Excited to be here. I'm going to tell you a little bit about Echo AI just to give you a context on the problem that Log10 and us have partnered on solving in terms of scaling applications in the enterprise. Echo AI is an application, and we partner very closely with Log10 in order to actually allow us to deploy this application at scale in large enterprises on 6 and 7-figure dollar value deals where the stakes are high and the potential value we can create for customers is also really high. So just to give you a quick background on what we do, our underlying, open secret is that customer conversations are the most valuable piece of data in the enterprise. Our customers are talking to their customers millions of times a day, and within those conversations are the answers to every single one of their questions. But it's this gold mine that they just can't. It's a gold mine that they can't extract right now. They can't take advantage of. You've got millions of words, billions of tokens in this big unstructured blob effectively, or, also millions of minutes of audio. Within that are all of these incredible insights that can really transform a business. Up until now, the technology really didn't exist to pull those insights out of those conversations. It's a perfect problem for LLMs, which I'll get into. Really, the reason why the CEO or the VP gets excited about buying our platform is that companies often become the victim of their own success, and it can be a virtuous cycle or a destructive cycle. The company starts and the founder talks to every single customer. They listen to customers. That's what makes them successful. They get more successful. They get more customers. At some point, the founder, the executive or leadership team is 5 layers from those customers. They stop listening to customers, and then they get displaced by a more customer-centric competitor. So listening to customers is the most important thing that every business should be doing. The way that our customers have solved this in the past, there are a couple of different ways that kind of map to the different generations of technology. First, and honestly, many of our customers still do this because it's the best possible option up until now, is manual review, where you hire a team of 5, 10, 15, 20 folks to randomly sample perhaps 1% of your customer conversations once a quarter to try to get a sense of what's happening. As often we call this a VOC, voice of the customer program. You can imagine all the issues with that. It's very expensive. You're paying for 20 people. It's a quarter in arrears. It's happening 4 times a year. It is not. It's not real time in any sense. You're relying on these humans who you need to train. They certainly don't have kind of executive level strategic insights. And so there's a lot of, and most importantly, you're missing 99% of your conversations. And then if you move into software, there are kind of 2 previous generations of software: speech analytics, which is effectively speech to text transcription and then writing really complex regex queries against those transcripts. So I want to track every time a customer asks to speak to someone's manager. I now need to create a regex query that, finds every single permutation of, I want to speak to your manager, supervisor, your boss, whoever's in charge. And so it's really complex to create. And maybe most importantly, you don't know what you don't know. You're only searching for things that you know to look for. And then, for what we call first gen AI insights are still incredibly shallow. This might be a sentiment model or kind of topic extraction or something like that. Requires a ton of pre-training and calibration, and is still multiple weeks and months in the rearview mirror. And so when I said that this problem is perfect for LLMs, you have this unstructured blob of billions of tokens that do contain gold insights in there, hidden in there, but you don't know what to look for. You couldn't even go mine them if you tried. With LLMs and with Echo AI, you've got an unstructured blob processing machine that extracts insights. And so our platform, our goal is every single conversation should be analyzed as deeply as possible. Every single word should accrete value back to the business. It should be happening instantly, and it should be completely generative. You shouldn't have to configure what to look for. We should be pulling out the things that matter to your business so that you can act on them. Just a quick example to kind of help you understand the level of depth that we're looking to achieve. And again, every conversation for us, I'll touch on this later, each conversation could be analyzed 50 different ways by 20 different LLMs. This is a good example of a customer conversation. My internet stopped working again. I think the router you sent me when I moved apartments arrived broken. It's really frustrating. I never had this problem with Comcast with them. I also got cable. From this, 3 sentences, we're extracting all of this structured data. The intent in contact driver is an internet outage. It's also notable that it's a repeat issue, could stop working again. The router was mentioned is also broken on delivery. You might have a supply chain issue. We're learning that this person recently moved. They probably rent their apartment. So there's an audience and segmentation insight that you could then sync back into your marketing team. Sentiment can be helpful, but it might be the least helpful thing in this. Intent, if an executive was reading this, if you as a founder are reading this, you would definitely say this person's a churn risk. Let's put them into a retention funnel. And there's a bundling opportunity, and they might be interested in cable. And then, of course, you've got the agent side of that conversation as well. So there's so much depth to pull out of these conversations if you have the right technology. Just really quickly, as just a real world example, one of our customers is wine enthusiasts. They used Echo, where within 24 hours of rolling out Echo, we detected a brand new manufacturing defect in their supply chain. A handful of customers had written in about it. They'd never seen it before. They never knew how to check for it. And so they were able to quickly detect it because the insights were generative. They would have never known to look for it. I want to really quickly show you a demo. Because it actually will perhaps speak to the what we're going to talk about with Log10. So this honestly should just look to you like vanilla SaaS that we've seen many times before. And the difference is that it's powered by LLMs on the back end. On the left, you have the unstructured data. This is an audio transcript, PII redaction, speech to text, kind of standard stuff, some cleaning. On the right is turning that into structured data. So each one of these is a LLM in the loop analysis job: summarization, tags, sentiment resolution, intent. There's agent performance scoring. Each one of these questions can go to a specific LLM. Our ethos, and I think the next generation of software businesses, their ethos is going to be LLMs in the loop for everything, because they just do a superior job across a variety of different analysis points. So this is what we're doing at a per conversation level. And then what we're able to do at a more macro level, and in this case, this is showing cancellations, is we're able to do macro analysis that is also totally generative. In this case, a customer has configured this account. They just want to understand why people are canceling their accounts. So here are the top reasons for canceling their accounts. It's completely bottoms up generated from all the conversations that have been reviewed. And then here are all the sub themes within this theme of move to a competitor. Technically, the way this works is this is a kind of an agentic hierarchy where you create this insight stream. Why are my customers canceling? Spin up a hierarchical team of agents to review every single conversation with that question in mind, and then extract insights, effectively do a map reduce to kind of get all the way up to this tree of themes and sub themes. So this is a super high fidelity long tail of reasons that are completely generative, and allows a customer to look at this and say, okay, the number one reason that people are canceling or move to a competitor, and it's because of environmentally friendly packaging. Who would have thought, right? And so if I fix my environmental friendly packaging, that's a 17% reduction in churn for this reason. So just a quick example of, and as I said, relatively straightforward software just powered by LLMs, and just kind of peeling back a layer and going under the hood, and this will tee up log 10 nicely, is again, the way to think about this is a data enrichment platform. We ingest customer conversations across every channel, and then we put it through a large and complex multi-step analysis pipeline, where, as I said, like every conversation could be analyzed 50 times by 20 different LLMs, taking unstructured data, structured analysis on top, and then making that available in the Echo AI application, as well as syncing that back into our customers' data warehouses and CRMs and CCaaS systems. So the key point of all of this is Echo AI is one of the first as part of that first generation of LLM native SaaS, and we're deploying into the enterprise. We're signing 50, 100, 500K contract, $1 million contracts with our customers to deploy this technology across millions of conversations. This technology is very powerful, but it's also immature, and accuracy along with performance and cost are some of the most important things that companies like us need to worry about and think about. And accuracy is the first, because obviously if it's not accurate, and isn't accurate enough out of the box, if it's not accurate, you're never going to convert that POC into a larger deal. You might not even, or you're going to get churn, or a low gross net revenue retention. But also, if you're not accurate and you don't have an infrastructure for increasing accuracy over time, then you can't increase your performance and improve your margins by going into smaller and smaller models, going from, let's say, a frontier third-party model to in-house fine-tuned models. That's a great process to do to decrease your cost and increase your own performance and throughput and handle your scale as you grow. But it only works if you're accurate. And so, and this is a very unique problem for this industry. Historically, software is very deterministic. 1 + 1 always equal 2. And so now there's this new, we have all this power and capability, but there's this new challenge. And so this was one of the first challenges that we recognized. And we've spent a ton of time building infrastructure and tooling around this, and very early on partnered with Log10 to be really the experts in helping scale technology like this. So with that, I'll pass it over to Arjun.
Awesome. Thanks a lot, Alex. Let's share my screen here. There we go. And yeah, so like Alex said, at Log10, we are building that infra layer to improve LLM accuracy for your B2B SaaS apps. And what we're driving towards is this vision of today, getting to good accuracy has tended to be a more manual process, requiring a lot of observability steps. But we're building the tooling that can automate both the observability as well as the process of optimizing the prompts and models that can ultimately drive better accuracy from the base models. And so just a little bit about us. We're a relatively new company. We started about a year ago. My background's been in AI for the past 10 plus years. Prior to this, founded a company called Nirvana Systems, which was one of the early AI hardware startups, which went on to be acquired by Intel. And my co-founder is Nicholas Nielsen, who was most recently head of product at Mosaic ML. and comes from a distributed systems background with training large language models. We're a team of 8 engineers and data scientists, and we just announced our fundraise of over 7 million last week. And so, yeah, today measuring and improving LLM accuracy has been quite challenging. And so when people have been going out and deploying these models out of the box, there have been some pretty public ways in which they've failed and cost companies a bunch of money. So you've probably heard of the Air Canada chatbot, which made up a refund policy, which a judge ruled that the airline had to honor. There was also this Chevy Tahoe chatbot where somebody sort of injected a prompt and convinced it that they could buy this truck for $1. We've run into the issue ourselves with one of our vendors. We were running into like a critical problem and needed help. And the chatbot was recommending that we play a cool game while we wait to get connected. And then there's also recently, even with popular search engines that are using LLMs under the hood, like Perplexity, where you could ask like a common sense question, which my 5-year-old could answer, but it runs into these kind of comical ways in which it fails. And so, people generally do have to put in something in place to evaluate the output of LLMs before they hit end customers, and that's tended to be humans. Human in the loop is still the gold standard for evaluation, but it tends to be time-consuming and expensive. And so people have also asked, what if you could use AI-based approaches? So use an LLM to grade its own output or another LLM's output. And the challenge with that has been that the approaches tend to be kind of biased and inaccurate. So these models tend to prefer their own output over the output of other models, even if the other model's output might be better. They also often prefer their own output over human, like domain expert output. So that's been a challenge. And there's also an issue with positional bias. So if you ask the LLMs to rate, let's say like 2 summaries, the order in which they're presented also has a big impact on which one is preferred. So in this case, the one that's presented first tends to be the preferred one. And then there's also things like verbosity bias. So just having longer answers with more diversity of tokens tends to be rated higher compared to shorter answers. And so that's where we came into the picture, and we asked, what if you could marry the human level accuracy with building an AI feedback system? And so we try to approach it in a way where the feedback itself could be very general. You could have anything from thumbs up, thumbs down, to scoring, to comments on the LLM output or corrections, have that be generated by the AI system so that you could address some of the issues that I showed before, where you could, for example, rank or triage the outputs that need to get sent to a human review. So you don't need to send everything for a human review. You could monitor or alert based on quality. So anytime the score is below a certain level, you gate that getting sent to an end user, so you don't end up with the kind of issues I described earlier. And then ultimately, you want to be able to use this AI feedback in order to improve the underlying model, whether it's through prompt optimization or through base model optimizations using techniques such as RLHF, RLAIF, or DPO. And so this is just an example demo app that we built for a customer support context, where before the AI-generated responses are sent to an end user, you also get a confidence score that's generated by our system, and that can help you perform these different objectives. And so just zooming out in terms of where we fit. So we fit in seamlessly between your LLM application and the LLM. And so through a very seamless integration, we basically tap into your LLM calls as well as the input and output of those calls. And so foundationally, we've built a LLMOps system that does things like logging, debugging, evaluation. As part of the auto feedback system, we collect the human feedback and help scale that through our proprietary AI system. And that helps curate this data set of input, outputs, and feedback, which goes into the auto tuning system, where you can optimize prompts and models through fine-tuning to ultimately get that better accuracy. So just I'll go through each of those sections fairly quickly, just to give you a sense of what they're about. So with the LLMOps layer, we talked to over 200 plus companies and looked at the workflow of how people were approaching building their LLM applications. And typically, you're sort of faced with this blank slate of how do you even write that initial prompt. So we have a prompt engineering Copilot that helps you with optimizing and getting to that initial best prompt, even from the get-go. And then once you've deployed that and you start collecting data, then we have the logging piece, which helps you capture the interactions that your end users are having with your system. And then within our platform, we also have integrated playgrounds where you can open up the input and output and experiment with different hyperparameters, different models to see how that qualitatively affects the output of what you're trying to achieve. And as usage grows, as things scale, it becomes tougher and tougher to be able to manually, qualitatively evaluate what's going on. And so for that stage, we have tooling that can help with quantitative evaluations in the form of LLM eval tool. And that can help you run things like parameter sweeps or run your ground truth data set periodically, whether it's part of a PR commit and getting status reports on a GitHub app, or running locally as part of individual developers' workflows. So this sort of ensures that you don't end up with regressions, either because of changes you made to your prompts or models or hyperparameters, or maybe you're using a third-party model and that changed and that might have caused some issues. So you notice that before your end users have to report that to you. And then finally, we also have integrated tooling for feedback, and hopefully I'll be able to show you a demo of how that works later on. But this basically lets you attach human feedback to any LLM call that's getting generated in your system in a very flexible way. So you can define the schema for the feedback in however way you choose. And then in the way that Echo AI were using us. So, the original prompt was typically set up by a solutions engineer on the Echo AI side. The feature was deployed and then used by Echo AI's end customers. And this data, as they were using it, was getting logged into Log10. And through a combination of the auto feedback and auto tuning systems, Echo AI was able to achieve a 20-point F1 score increase in the LLM application. And we describe this in more detail in our case study that's available on our website. And so with Log10, it's really easy to get started. We thought a lot about developers and how to make the integration really seamless. So it's literally just a one-line change. So instead of importing OpenAI from OpenAI, you import it from our Log10 library, and nothing else in the code needs to change. And basically all your LLM calls start getting logged and start showing up on our platform through that just one simple change. And we have similar integrations for the other LLM providers. At this point, we include Claude, Gemini, Mistral, Together, Mosaic. We support self-hosted as well. And and we'll go through the demo in a little bit, but basically this is what the interface looks like. We support things like tagging, an extensive search system, so you can immediately drill down into whichever logs are problematic and start diagnosing issues. And then we have the detail view where you get details on things like the metrics, tokens used, cost, latency, and so forth. So there's additional hyperparameters that can help with debugging issues. This is a bit of what the typical workflow look like, still more in the qualitative stages where you have logs and maybe there was a particular customer or a particular session that had an issue. It could be identified with a unique ID. And the unique ID basically lets you go into this kind of a view, find which tag it was, open up the specific log, which might have been problematic, and look at the details, open it up in the playground there, and invoke things like the prompt engineering Copilot to give suggestions on how the prompt could have been improved to make it more accurate. So that's kind of one canonical flow that Echo AI and others have been using to both diagnose issues and improve the accuracy. So next, moving on to the auto feedback section. So we have visibility at this point into the logs. We have a way to collect feedback and sort of how do we get to the heart of the matter of scaling that human review in an accurate way. And for this, we've basically built a system that lets you bootstrap with as few as 25 to 50 labeled examples, much more synthetic data, which is used to then fine-tune this custom evaluation model that's trained on your specific data. And we found that this is very useful in use cases where there could be high volume, for example, in customer support, or there's some specialized domain knowledge that you're trying to evaluate, for example, in healthcare, or cases where the ratings might be very subjective. So you're trying to write in the brand guidelines or style guidelines of your company, in tasks such as summary grading, and finally being able to calculate an independent measure that's not correlated with just the base foundational model, because like we saw before, those tend to have these kind of biases and inaccurate evaluation issues. So this is just a quick peek into the system architecture. So we have the end user who's calling the product feature that uses the LLM. That goes in turn generates the AI response. And you have the human reviewer initially providing the feedback, which to get the input, output, and the feedback is all getting logged into log 10. Under the hood, the auto feedback model starts getting trained. And once it's reached that point of about 25 examples, it can be basically used in inference mode. So any new AI call that's happening triggers an inference on the auto feedback model and gets available, that the automatically generated feedback becomes available to the human reviewer. And it can be used for triaging, monitoring, alerting, or even overlaying corrections so that they have a better draft to start off with and if they're going to be making further edits. And over time, as the auto feedback model is giving you signal on quality of the LLM generated output, it helps you curate that subset that you can then use for tuning the underlying model. And that's where our auto tuning system comes in and helps fine tune the model or optimize the prompts to get to better accuracy. Mostly covered this, but this basically shows the dashboard that you can then see in terms of the stats that are generated by the auto feedback model and aggregating those to get a view on, you could get like a daily accuracy view on how well your LLM has been doing from day to day. And basically, it's very flexible in terms of how you use that signal to power these downstream use cases. And then on the auto-tune front, like I mentioned, we basically use the quality signal that's coming out of the auto feedback model to be able to curate these data sets. One of the main thing that ends up being needed to improve accuracy whether it's through prompt engineering or through fine-tuning, is having really high quality ground truth data. And traditionally, the issue has been the cost and time needed to collect that and make it high quality. But the auto feedback system naturally gives you a signal on all the data that's coming in through the system. And you could say that everything that's above, let's say a 70% threshold, I'm going to use as the data that goes into my fine-tuned model. And through the auto tuning system, basically that's like different models, different prompt changes get evaluated on your behalf, and you get surfaced the best prompt or model that'll help you improve accuracy. And I won't have time to demo the prompt engineering system, but we have a link to that in our docs if anybody is curious to try that out. And where we're going with this is basically the ability to, as you have data flowing into the system, you'll have some part of it getting human feedback, but a vast majority of that, which traditionally wouldn't have gotten that human feedback, can now get the AI-based feedback. So overall, whatever data you have available to your improvement cycle, like to the auto-tune system, is much bigger than what you'd have without the auto feedback system. And so basically over time, your AI system is getting better and better with very minimal work needed on your part, or very little manual work needed, basically, and eventually no manual work needed. So quickly just going over the results. So we published a blog post showing that our system works. So if you just use GPT-4 as a judge out of the box, you would notice these kind of bias and accuracy issues, where in this case, it's just predicting 7 for everything. Whereas with the locked-in system, it more closely mirrors the ground truth. And at an aggregate level, we showed that through our system, you could get a 44% reduction in feedback prediction error versus just using a naive few-shot learning-based approach. We also showed that it's very sample efficient, so you could start from as few as 25 to 50 examples and get to the accuracy of as if you'd had 600 examples. And in some work that we've done since then, we've shown that this can basically keep scaling in an exponential way. So for every new example that you're getting, we're able to use that in a very sample efficient way to drive accuracy. And then finally, with Echo AI, like I mentioned, we have been able to drive up accuracy by 20 F1 points. And basically just through the prompt optimization, we were able to get better mean accuracy than compared to even using fine-tuning and other approaches in the market like DSPY. And then, yeah, I guess we do have some time, so happy to do a demo here of the system. So our system is available as a self-sign-up, and it's free to get started. So definitely encourage folks to go to locked.io, and there'll be a sign-up link there. So do sign up, and it'll help kind of follow along with what I'm showing next. And as a companion to the web platform, we also have a Python library, which is one of the ways in which you can integrate your LM application with Locked-in, and very simple one-line integration for OpenAI and a bunch of other LLM providers. And once you do go in, just to give you a sneak peek, basically this is what you would see as log showing up. This is kind of our own view, but you'll get more of an onboarding experience as you log in. There's feedback. That's the main view for where all the feedback shows up. And models is another pane where all the registered LLM providers will show up. So you get a view into that in one place. And then next, we have published a few cookbook examples. So that's also open source in our cookbook repository. And I'll walk through one of these examples, which will showcase the flow going from logging to feedback all the way to auto feedback. So I have gone through, so this is the example I'll be going through. This is in a summary grading task use case. The data set was from OpenAI. It's the TLDR data set. I'm using the news part of it. And the first two steps of installing dependencies and vars I already ran, just to kind of not leak all my keys on the internet. And then after that, the next step will be creating a task. And so let me just give it a different name because I was testing it last night and it'll be easier to differentiate. And so the task itself can be defined with this schema. It's very flexible. So in this case, the task had these axes along which you were trying to grade summaries. So these are coherence, accuracy, coverage, overall, and the data set also has notes attached to it. So I'll just run this block. And when I go in, oh, I might have lost my, let's see. It's gonna make me, just gonna take this off screen for a bit, just so I don't expose my keys. Great. Okay. Sorry about that. Okay, great. So yeah, there was a bit of setup there, but yeah, basically I also had to just set up the tag selector, which is the way that new logs that are showing up will show up in the inbox view that we have in our product. And so in the task panel, it shows this summary grading task that I just created, and it has those 4 axes. And it also has the instructions that were set up for, and these would basically be the instructions that you would give a human reviewer to grade the summaries. And that forms a part of the prompt that goes into the auto feedback system to try to automate that human review process. And then next, basically, this is the prompt for what will be actually generating the summary. So this is more like a test prompt. And obviously in a real system, you would have a much more sophisticated prompt for generating summaries, but this just sort of illustrates the input output of what's going into the model. And then for the first example, this is a news item about Newcastle football team. And so we'll generate a summary using GPT-4 Turbo. So let it generate. And then that summary will basically show up on our logs here. So that was the article, that's the summary. And we have all the hyperparameters associated with it, input tokens, output tokens, cost, and so forth. And then because I tagged it with the same tag that I used when I created the task, it shows up in my inbox as something that needs grading. And for this first example, I'll basically do that programmatically. So I'll show how you can basically pass in the feedback through the Python SDK in this case. And the idea here is basically in your applications, you could connect the feedback that you're getting from your end users directly into the system. and have it show up here as well. So let's just refresh here. And yeah, so now that it has feedback attached, it ends up in the feedback stream. And so it shows up over there. Another kind of code path could be where you have the feedback, where you have the summary coming in as before, but we want to go in and actually assign the feedback in the UI. And this could be a use case where you have domain experts in-house, and they're going to be going in and attaching the scores in the UI. So just sort of mimic that flow here. So, let me say, want to attach 5, 6, 7, 7. And I can review the summary and sort of make the call on how much I want to grade it, and basically hit save. So that's kind of another way in which the summaries can be provided, the feedback can be provided into the system. And then finally, this is the auto feedback approach. So I'll generate another summary here for a different article, and let that run. And basically at the end of that, I'll get this completion ID, and that's used to register the output from the LLM call to the thing on which I want to run my auto feedback model. And so in this case, it's like a very simple auto feedback model. It's just using that one example that I gave before and running a very simple ICL model. But on the managed platform, we have these custom fine-tuned versions of these feedback models as well. So let that run. And yep, so now it basically returned a JSON blob with those feedback fields that were populated by the auto feedback model. And now I'm just going to extract those fields back into a feedback object that can be sent back to our API. And just closing the loop here. So there's a third feedback example that now has the feedback populated by the auto feedback system. So yeah, so that's basically it for my part, and I'll hand it back to Alex for the conclusion.
Great, thank you. Arjun, why don't you just share screen again?
Sure, yeah.
So kind of tailored two different presentations here. I started at the application layer and then with Arjun at the infrastructure layer, but at the end of the day, it's a partnership that is required in order to deploy software at enterprise scale. And so for Echo AI, what working with Log10 and using nearly the entirety of their platform has enabled, first and foremost, our solutions engineers are able to optimize prompts, deploy to customers with super high accuracy in a handful of hours versus days or weeks. That's not only increasing amount of work for our team, but it also decreases customer trust. The ability for anyone in our team, or solutions team, or engineering team, support team, to solve prompt issues, to go to the logs, to do that in a single environment, and to also kind of view the more macro level metrics that Log10 provides has been incredibly valuable. And so what we are able to do is keep the solutions engineering team very small and high powered, and 10x their ability to onboard new customers. And so that was the kind of first step. And then as we started using Log10's auto-tune system, that started providing an even greater benefit or boost to accuracy by taking our unique data and logs and suggesting and working towards more accurate workflows and prompts and fine tunes. And so as a result, we've been able to successfully deploy to some of the largest LLM native contracts that we've heard of, and to do so accurately. And that's just in partnership with folks like Log10. So if you're building in the application layer and you're trying to deploy something where accuracy is important, I highly recommend working with Arjun and his team.
Awesome. Thanks, Alex. I think you covered this part as well. Great. Yeah. And we do have a generous self-service free tier. So I highly recommend everybody sign up at log10.io. And I posted a link to the notebook examples in the chat. And happy to take any questions if anybody has any questions. Feel free to drop them in the chat. We'll probably stick around for a couple of minutes here. Running the notebook requiring API keys. Yeah. So for the notebook, we need, in this case, OpenAI API keys and Log10 keys as well, which at least for the Log10 keys, you can get them for free once you sign up. And happy to kind of show that process here. So once you sign up, so you'll see the org keys show up there. And this is just in my demo account, so hopefully not too bad. And then the AF, like your actual keys will show up there. So, yeah. Awesome. Any other questions? Great. Yeah, I'm available at my email, arjun@log10.io. I also have a Substack, and our team has been contributing blogs into it for best practices on how to use LLMs in production. It's just my first name and last name, arjunbansal.substack.com. And I'm on X at Coffee Phoenix. So yeah, look forward to hearing from you all there. And thanks a lot for your time and attention.